In this video, we will solve another interesting problem called Buffons needle. Okay, so it goes like this. Now imagine we have a plane or a paper with these horizontal lines, with these blue horizontal lines. Okay, please ignore these vertical gray lines. Those came as part of the plotting, but we'll have only these blue horizontal lines. Now, let's say they are separated by one unit distance. Okay, so the distance between these two horizontal lines is 1 unit, and those are all equispaced. Okay, those are all equispaced. Now, we have the needles of length again 1 unit or 1 meter, right? The same as the distance between these two horizontal lines. Now, similar to the raindrops or pi problem we solved in one of the previous videos, let's say from the top we are dropping these Buffons needles. Okay, so the Buffon needle length is 1 unit. Also, the distance between these two horizontal lines is also 1 unit. Okay, now when we drop these needles, they fell over this plane, right? Now some of them interact with these blue lines, like this one, like this one, this one, like this one, and some of them don't, right? Like this one, like this one, and this one. Now the task is to find out what is the probability that the needle will intersect with these one of the blue lines. Okay, it cannot do with the two lines because the length is exactly the same, unless it fall exactly uh, uh, in 90 degrees angle where it might touch both the horizontal lines, right? And from this probability, we can also compute the value of the pi. Okay, so let's see in this video how we set up this system and how we generate these needles, and hence we measure if they are intersecting with the lines, find the probability, and finally compute the value of pi. Okay, all right. Now, so simulating this plane is easy because all we have is just this imaginary horizontal lines separated by a distance of 1 unit, right? So these lines are at, let's say, 0, 1, 2, 3, 4, 5, 6, and so forth. Now we need to generate these Buffon needles, which means we need to generate two coordinates, right? One is this point, the other one is this point. So this point will have two coordinates xy, and this point will also have two coordinates xy. So essentially, we need to generate 4 points so that, but there is a constraint, right? The distance or the needle length should be 1 unit. Okay, so what we do is we generate 1 point or xy coordinates, x1 and y1. So we generate, let's say, you take any one of these. Let's take, for example, this one, right? This blue one. So we generate x1 and y1. So this one end of the needle coordinate. And then instead of generating x2 and y2 with the constraint that the unit length should be equal to 1, what we do is we generate an angle, right? An angle between 0 to 3 degrees. So what we do is, let's say we have generated a coordinate x1 and y1. We generate an angle theta, and from trigonometry we know this forms a right hand triangle, and we already know the length of this needle, which is 1, or it could be any arbitrary L length, right? If the length of the needle is L, then the spacing between the horizontal lines should also be L. Okay, now from trigonometry we know the coordinate x2 will be equal to x1 plus the length of the needle, in this case 1, times the cos theta. Theta is this angle, right? Similarly, y2 coordinate will be y1 plus the length of the needle times sine theta. Theta is this angle. So what we do is we generate two coordinates x1 and y1. We generate the angle theta, and using these equations we compute x2 and y2. So this way we are already satisfying the constraint that the length of the needle should be equal to 1, right? So this is just a convenience to generate the second coordinates with that constraint 1. Now the tricky part is, okay, we have generated the needles, we place them on the plane. Now how do we find if the needle is actually interacting or intersecting with these horizontal lines? So what we do is, here are two scenarios: one where the needle is not intersecting, one where the needle is intersecting. So what we do is, so imagine these are our horizontal lines, we dropped a needle, so let's say the needle has fallen like this. Now what we do is, uh, because the needles are along the y direction, whether the intersection happened or not is dependent purely on the y coordinate, not on the x coordinates, right? So what do we do is, first we take the minimum of y coordinates, right? For example, so this is 1 point, this is 1 point, so here we have y1, here we have y2. Now in this case y1 is smaller than y2, but it need not be, right? For example, if the needle falls something like this, y1 will be higher than y2. Okay, so it doesn't matter which one is higher, which one is lower, but what we do is, we'll take the lower value of y, which let's say in this case happen to be, let's say, some 0.3, right? So if this is 0, this is 1, let's say 0.3. Now we apply seal, which means we are rounding it up to its nearest integer, right, on the higher side. So essentially we have converted this y1 equal to 1 in this case, right? And similarly, for the larger coordinate, which is in this case y2, we apply the floor. Okay, the instructions are here, you can read through. So we have converted this y2 to 0. So in such a case, the needle does not interact with any of the lines, right? Whereas in a scenario like this, here again we have y1 smaller, y2 larger. So we apply seal to y1, which means this coordinate we transformed it to 1, or we computed a new value which is equal to 1, and to y2 we have applied the floor, so the value has become 1. So if the result from step number 2 and step number 3, which is applying the floor and seal functions, if these two happen to be equal, that means the line or the needle intersect with one of the horizontal lines. So that's how we are going to find out if the needle intersect with the horizontal lines or not. Okay, so let's see how we generate. All right. First we generate only 100 needles. This is for demonstration purpose, but this will not, as you know, this will not give the right probability, because if we generated, let's say, 100,000 or a million needles, we wouldn't be able to see this image this clearly, right? So that's why first I ran this experiment only with 100 needles. Okay, and here we have the number of hits. To begin with, it is 0. Now we are going to generate lots of needles, right? 100 needles, which means each needle will have 4 coordinates. That would be x1, x2, y1, y2, or here I call them xi, xj, yi, yj. Okay, so for each needle we are going to have the 4 values stored in these variables, so that at the end of the experiment we can plot the needles here. All right. Okay, so let's generate the needles. Now let's say our plane start from 0, in the y coordinate start from 0 and all the way up to 11, right? So we want to generate the y coordinates between 0 to 11. Now in the horizontal direction, it doesn't matter, but just to make it square-like, we will do the same dimensions. Now in the horizontal lines, it can be as long as you want. It can be 100,000, it doesn't matter, right? Only in the vertical direction, we have this constraint that the plane or the paper is from 0 to 11. So what we do here is, so here we are generating one coordinate for x1, okay, which will be between 1 to 11. And then this will be 0, so this will be 1. And then similarly, we are generating this y coordinate using the same similar method, right? After that, here we have generated the angle. We have simulated this angle. So we generated two coordinates x1 and y1, and then we are picking up an angle theta, right? That's also we are generating randomly. Okay, so this angle will goes between 0 to 2 pi, right? Because we know this n pi rand function, it will generate a random number uniformly between 0 to 1, right? So here we have generated a theta between 0 to 360 degrees. Now our x2 and y2 coordinates are simply be x1 plus the length, in this case happen to be 1, so x1 plus cos theta. Our y2 will be y1 plus sine theta. Okay, so y2 will be y1 plus sine theta. So here by this time we have generated one needle. So we have generated a x1 y1, we have generated a theta. Using these three values, we have computed the x2 y2 values, which means we have generated one needle. Okay, so with this code we have generated one needle. Now we are checking if the needle intersect with one of the lines. Now as we discussed before, it's very easy. All we do is, using the y coordinates of the needle, first we will find out the minimum value of y, and then we apply the seal function to the and to the max y value we apply the floor function. Now the result of these two transformations is not the same. That means the line don't interact, the needle don't interact with the lines. If the result of these two happen to be the same, which is in this case, then that means the needle intersect with the lines. So all we are doing is, first we are finding out the minimum of y1 and y2. Okay, the minimum of y1 and y2, and then to the minimum we are applying the seal. Okay, to the maximum we are applying the floor. Okay, so to the minimum we are applying the seal, to the maximum we are applying the floor. Similarly here, to the minimum we are applying the seal, to the maximum we are applying the floor. Now the result of, if these two operations is equal, then that means the needle is intersecting with the lines, otherwise not. Okay, so here we are checking. Now if the result is the same, that means it's interacting, which that's a hit, right? So here we are increasing the hit by 1. So the check will have a value of either 0 or 1. If these two are equal, then it will be 1. If these two are not equal, this will be 0. So if they are equal, that means the needle intersect with the lines, and that means we are increasing the number of hits by 1. Okay, and finally we are saving the needle coordinates in these lists so that we can plot them at the end. All right, and finally the probability of the needle intersecting with the lines is simply how many lines or the needles have interacted with the lines divided with the how many needles we have dropped, right? So for this small experiment we dropped a total of 100 needles, and then the number of needles intersected is 56, which means the probability of intersection is 0.56. But again, as you know, this number is too small to say this is the right probability. But now mathematically this probability will be equal to it's 2 times pi, which means the pi value will be the probability will be 2 divided with the pi. Okay, again we are not going into the mathematical derivation of this problem, but the probability will be equal to 2 divided with the pi, which means if we reorganize the variables, pi value will be equal to 2 divided with the probability. So 2 divided with 0.56, we have got a value of 3.57. But let's do one thing. Let's increase the number of needles, and let's recompute the probability. Okay, let's rerun this. Yeah, as you can see this time, this is the probability of intersection, and the pi value is also very close. So it's 3.14, right? The actual pi value. Now it's this one. Let's increase one more digit. This simulation might take a bit long, but let's do this. All right, 3.149. So here we are getting very close, 3.14 to the actual pi value. And here all we are doing is simply we are just making this grid, these horizontal lines, and we are plotting the x and y values. Here for the plot layout, we choose a square layout so that we can see it clearly. Okay. All right, that's it for this video. Thank you very much.